Boys, you don't know how many damn takes it's taken me to do this video so far, but we're going to try another time. But about a year and a half ago, I posted a video about Justin Fields. And listen, I am an Ohio State fan, so clearly I was very biased. But there were a lot of people out there that were a lot smarter than me and knew a lot more about football than I did, that held the same opinion that I did. And that is that Justin Fields is going to be a good quarterback in the NFL. And boy, was I incorrect. But I needed to redeem myself, all right? That's my most popular video. I had about like 20,000 people watch it. And I look like a complete buffoon in front of all of them. So I need to find a way to look intelligent in front of my viewers. And I thought, what better way to do that than to mathematically lose money while betting on NFL games? But yes, this is going to be a very wide departure from my usual videos of doing film analysis and stuff. But I am going to be using machine learning, artificial intelligence, modeling stuff in order to mathematically gamble on NFL games. This is totally going to work out great. But here is a quick overview of the system, like the architecture behind this model and how it works, what's the goal of it, and what am I going to do with the information that comes out of it. I will preface this with saying that I only like 75% know what I'm talking about. So I'm really hoping that there's just a bunch of previous high school athletes who are now college kids and have a minor gambling addiction that are watching this video. Therefore, when I mess something up, I have no one to actually correct me. But if anyone has ever used artificial intelligence before and knows anything about it, they know the most important thing in the first step in the process is getting one metric fuck ton of data, which you think will be pretty easy to do. It is the fucking hardest thing to do in this entire process. It took me like 2 weeks just to get all of the game stats for every game for the past 10 years. You would think that'd be really easy to find, right? You think there'd be like an Excel sheet somewhere that you could download, or just something you could copy and paste that has every game in the last 10 years and like some of the statistics behind it. But no, I had to jump through way too many hoops to find this information. So please be proud of me. But so far, the data that I have are just going to be basic game stats. So how many rushing yards a team had in a game, how many passing yards, how many turnovers, how many first downs, stuff like that. Also the score of the game, of course. And I was able to use that data to come up with a bunch of calculated fields. So, for example, just making up an example here. So, November 2014, the Bears played the Packers. And going into the game, the Bears were 4-6, and the Packers were 8-2, and the Bears were averaging 300 yards of offense a game. The Packers were averaging 400, stuff like that. Obviously, as well as who won the actual game. Then I also need data on the sportsbook odds so that I know whether or not I'm getting a good deal on the bets that I place. The next step in this process is that I take all of this large clump of data and I shove it into what is called a logistic regression model. So this is a type of machine learning model, AI model, whatever you want to call it. And I'm just going to go into like a quick overview. You don't need to know all the intricacies, but basically you take all of this historical data, you put it into a logistic regression model, and you train the model on that historical data. And then when I asked the logistic regression model, Dallas is playing Seattle this weekend. What's the probability that Dallas wins the football game? It's then able to spit out a number for me, which my made-up number is 55.56%. So basically, the model is able to tell me that Dallas has a 55.56% chance of winning the football game. That's all fine and dandy, right? We now know that Dallas has a 55% chance of winning the football game, but what do we do with that information? Do we bet for Dallas because they're favored? Do we bet against Dallas because we might have good odds against Dallas? Well, that's where the sportsbook odds come in handy. But what we do is we take the sportsbook odds and we convert them into probabilities. So, for example, in this made-up example, Dallas is minus 200 to win the game, and we are using money line. So Dallas is minus 200 to win the game, and that equates to a 66.67% chance that Dallas is going to win the football game in Vegas's eyes. Now, obviously, there is quite a difference between 66% chance that Dallas is going to win and 55% chance Dallas is going to win. So what do we bet on now? Well, we're going to use something called a margin of error to bet. And I think what I'm going to end up using with my model is about a 5% margin of error. That might change over time. But if these bets differentiate by 5% or more, I will make the bet that favors my probability. So in this example, Vegas thinks Dallas has a 66% chance of winning. Mine's about 11.1% lower. Therefore, I will bet on Seattle because the odds are in my favor. You might bring up a very valid point. You might say, hey, listen, Krusty, like, we're very proud of you. You're able to come up with your own probabilities. You have your own model. You prove that you know how to do this stuff, and you're not a complete idiot. But Vegas is way smarter than you are. They hire way smarter people than you. They also have a lot more data than you, and they're an entire organization, and you're just one guy in his basement. Therefore, their odds of 66% are definitely more accurate than your odds of 55%. And that is where you are probably right. But you might be wrong. See, the thing with Vegas is that they don't try to make the most accurate odds possible. They try to make odds that the public believes are the most accurate odds. And what I mean by that is they want to have 50% of the money on one side of the bet and then 50% of the money on the other side of the bet. So they want 50% of the money on Dallas and then 50% of the money on Seattle. And the reason for this is this guarantees them profit. No matter who wins this game, it guarantees it that Vegas wins money. So maybe their 66% is higher than my 55% because the public opinion thinks so. And if Twitter has taught me anything, it's that public opinion is trash. That's how I'm going to take advantage of sportsbook systems in order to hopefully make money sports betting. Now I'm going to go into some of the nerdy details of this because I'm very proud of myself that I was able to do this. And for those of you degenerate gamblers out there, maybe you should take a minute and learn something. But if you don't want to learn something, then skip ahead to this time in the video. I'll display it on my screen. But let's hop into the nerdy stuff. So the way that I was able to find all this data on every single game, I tried different APIs, which is basically like I would connect to like someone else's database and pull information from that database. But either their like free trial wouldn't allow me to pull enough data, or it was too expensive for me to actually purchase it. And have you seen the amount of views that I get? Like, I don't have thousands of dollars laying around every month in order to afford to make a video. So what I did was I went to ProFootballReference.com, which I've never been before. It's a great place to get statistics on NFL games. And I figured out they have this schedule page, and this shows you every single game that was played in like that specific year. And obviously I can look at other seasons as well. I can how the fuck do I get there? I can like look at other seasons as well, such as the 2020 season, go to their schedule. And I was able to write some code, and I'm not going to go through how it works, but I was able to write maybe a lot of code that went to every single page and changed the URL every time. So I would change this to like start at 2012, and it would pull all the data from this page. And then it would go to 2013. And it would pull all the data from this page, and it would do that from 2012 up into the current year. But also, it had to go into I had to go into these box scores as well in order to get some more information on these games, get any other data I could find. A lot of this is going to be used in this model in the future, but I just haven't input it yet. One of the most annoying things about this was the naming conventions on some of these URLs. So take like Denver, for example. You go in the URL, it gives you the date, and then it says Den, which obviously is an abbreviation for Denver. So that makes sense, correct? You think it would go with like the normal abbreviations that every team goes by. However, let's take a look at the Titans naming convention, all right? So Denver's DEN, so you'd think the Tennessee Titans would be TEN because that's what they usually go by all the time. No, it's fucking OTI. Why is the abbreviation for the Tennessee Titans OTI? There isn't even an O anywhere in that name. So I don't know if I'm missing something here, or I have no idea. But it is OTI, and then I also had to deal with like obviously the Raiders went from Oakland to Las Vegas, so I had to deal with a naming convention change there. Little stuff like that, but it's kind of a very annoying process. But this script that I wrote right here, all this code right here that I did in Python, I was able to kind of search through all these HTMLs and find the data that I was looking for, put it into what is called a data frame, which basically is like the coding version of like what an Excel sheet looks like. And then from that data frame, I'm able to import that into an actual Excel document. So for example, this is what the final Excel document looked like. September 5th, New York Giants played the Cowboys. The score was 17-24. The home team lost, and here's how many yards they had, turnovers, first downs, passing yards, stuff like that. With that, I was able to throw together like a bunch of different calculations that I would use in my model. So the goal of the model was to predict this home W, so that's whether or not the home team won. And then everything in yellow, not in tan, in yellow is something that is used to predict that. So, average yards the home team had, average yards allowed by the home team in the games previous, stuff like that. So that's kind of how I threw all this together. There's a ton of different information here, like how many rushing yards, passing yards allowed, turnovers. This is like how many rushing yards does the home team average minus how many rushing yards does the away team allow every game. So different calculated fields like that I utilize in order to kind of run this model. All right, so I'm shooting this out of order. So I believe I just went over how I acquired all of the data and put it into a spreadsheet. Very fun stuff, but this is the stuff that I find really interesting, and it's logistic regression. So this is a type of machine learning modeling. I'm just going to go over a quick crash course on what logistic regression is. I had this very simple example here. On the bottom axis, we have record. So the record of the team going into a game. And then on the y-axis, we have whether or not that team won or lost that game. So, for example, this data point right here, you could say that would be like the 2007 Patriots, who were 15-0 going into their 16th game of the year. And they ended up winning that 16th game of the year to go 16-0. So their point goes right here because they had a 100% win rate going into the game, and they ended up winning the game. This example right here would be like the 2017 Browns that were 0-15 going into their last game of the year. They ended up losing that game, and their data point goes right there. And then obviously in the middle you'd have the Denver Broncos 2022 when they went to play the 49ers in week 3. They were 1-1 going into the game, so they had a 500 record, and they ended up winning that game. So they go up in this one column, this win column up here. So, and what logistic regression does is it builds a kind of a correlation, like a line between these. Builds what is called a sigmoid function, which sounds all fancy, but really it just builds a line that looks like this. Something to that effect. And what this line says is, okay, if a team goes into a game with a 500 record, then they're going to have a 0.5% chance of winning that game. So if a team goes into a game with a 500 record, with that information, we know that they're going to have a 50% chance of winning that game. And then obviously, if a team goes into a game with a 75% win rate for the season, then they're going to have, roughly a 75% chance of winning that game. But we are using a lot more than just record in order to actually calculate this logistic regression model. So what does this look like when you have 25 different variables? Well, sadly, I would need a 26-dimension graph in order to showcase that to you. So I really don't have a way to visualize this, but just understand that on a basic function, this is what is going on in the background. It's building this kind of sigmoid function or line, which tells us what the probability is of a win or loss, depending on what variables we give the model. All right, boys, enough of the nerd talk and going over the model. Let's actually see what this model output, what it spit out for us. So I put the actual model predictions of percent chance to win right there for both the home and away team. And then I put the Vegas odds and converted that into like an actual percent chance that team's going to win. Did the same thing over here. And one thing that I never thought about that I really should have been able to figure out a lot sooner was that the Vegas odds are not going to add up to 100%. So for example, the Vegas odds show that the Saints have a 45% chance of winning. but they're playing the Vikings, and the Vikings have a 59% chance of winning. Obviously, those don't add up to 100%. It's over 100%, and that's because that's the profit that Vegas takes away if there's 50% of bets on each side. So with all this information, I was able to calculate an expected profit if I were to make each bet. Obviously, there are some of these bets that I like according to this model would still be profitable with. So like I would be profitable betting for the Colts to beat the Titans, and I would be profitable for the Falcons to beat the Browns, theoretically according to this model. However, it is not within my margin of error of 5%. So for this example, obviously, Vegas has the Texans at a 35% chance of winning. I have them at a 46% chance of winning. It might be a little wrong, but hey, we'll see. Obviously, that's outside of our 5% margin of error. Therefore, we want to place the bet on it. The expected profit is enough. So one thing I did notice about this model is it likes underdogs a lot. Vegas seems to favor good teams a lot more. I mean, the Packers have what is shown as an 83% chance of winning the game, which, I mean, if you think about it, if any two NFL teams play 100 times in a row, one team winning less than 17 times out of that 100 games, like that's a pretty low. Like NFL games are close. Like that's tough. Like I don't know about that. So that's where I think we can kind of take advantage of this. Is that obviously like the Packers odds are very high. The Patriots, they're playing the Patriots, and the Patriots have like a 21% chance according to Vegas. I think they have a 39% chance according to my model. Therefore, I place a bet on it, and that is the most profitable bet. One thing to obviously keep in mind, I think I mentioned this earlier, but I put danger for these two games because my model does not account for injuries, and obviously going into this week, the Jets and the Patriots are both. I guess the Jets don't have injuries, but they have Zach Wilson coming back from injury. So their performance is going to be a lot different when they have Zach Wilson playing quarterback as opposed to when they have Joe Flacco playing quarterback. And then the Patriots are going, Mac Jones got injured. So all of the data that I have input on the Patriots so far this year is with Mac Jones at quarterback. And now Brian Hoyer is quarterback. So that could significantly affect the outcome of the game, and that's not included in the model. So I might stay away from these bets. We'll see. I think I'm just going to bet on the Dolphins, Jaguars, Texans, Cardinals, and Broncos and see what happens. Also, I can change my margin of error right here. So say I change it to 3, there's going to be more teams that it wants me to bet on. Say I change it to 10, there's going to be significantly less teams they want me to bet on. And I could change it to 0, and basically any bet that it believes will be profitable would be bet on. So pretty cool tool, something very fun to kind of fuck around with a little bit. But yeah, honestly, that's pretty much it for this video. I really hope you guys enjoyed it. I usually don't do a very long outro, but I really do hope you guys enjoyed it. This took me so long to put together. And it's something that I kind of wanted to do for a project for myself, but I also thought it would make a very interesting video. So yeah, I hope you guys liked it.